What if everything we thought about AI was wrong? For years, the race has been about size, more parameters, bigger datasets, endless GPUs. But Microsoft just shattered that illusion. They've created an AI system that isn't just powerful, it's lean, efficient, and frighteningly intelligent. Imagine a smaller model outperforming the largest AI giants ever built. Sounds impossible, right? But it's happening right now. And here's the twist. It was trained in only 7 days using just 64 GPUs. That's not a typo. While the rest of the AI world is bragging about burning through tens of thousands of GPUs for months at a time, Microsoft quietly pulled off something so efficient, it feels almost unfair, and they didn't stop there. Alongside this breakthrough, they've rolled out 2 brand new models, a voice AI that can generate a full minute of human-like speech in less than 1 second, and their very first in-house foundation model, trained at an unprecedented scale on 15,000 GPUs, now being woven into Copilot. This isn't just another upgrade, it's a turning point in how AI is built, trained, and deployed. If you've ever wondered where the future of technology is headed, buckle up. Because what I'm about to show you isn't just innovation, it's disruption. Let's dive into Microsoft's R2 agent, and why it could mark the beginning of a completely new chapter in AI reasoning. Section 1. The flaw in AI reasoning, and Microsoft's radical fix. We've all heard the phrase, chain of thought. It's the backbone of how large language models try to solve complex problems. The logic is simple. If you let an AI think out loud step by step, it will catch mistakes along the way and eventually arrive at the right answer. In theory, that sounds flawless. In reality, it often fails spectacularly. Here's why. If the AI takes a wrong turn in its very first step, it usually doubles down on that mistake. Like a student confidently solving a math problem but messing up the very first calculation, the rest of the solution is doomed. No matter how carefully the steps are written out, the conclusion is fundamentally broken. Microsoft's researchers saw this flaw and asked a daring question. What if thinking longer isn't the solution? What if the model needs to pause, check its work, and adapt, just like a human would with tools? And that's exactly where the R2 agent comes in. Unlike traditional AIs that spit out text in a straight line, R2 doesn't just think, it acts. It uses a technique called agentic reinforcement learning, which lets it interact directly with a Python environment while reasoning. Imagine giving an AI not just a brain, but also a calculator, a scratch pad, and a debugger. When it faces a math challenge, it can pause, write code, execute it, read the results, and decide whether it's on track. If the numbers don't add up, it adjusts and retries, just like a human problem solver. This shift is profound. It moves AI away from rigid, one-directional reasoning and into a dynamic back-and-forth process. That makes it not only smarter, but also far more reliable, and reliability. In a world where AI mistakes can cost billions or mislead millions, is priceless. But of course, this kind of intelligence doesn't come for free. Training a model to constantly use tools and check itself creates a storm of computational chaos. Picture tens of thousands of code snippets being written and executed simultaneously. Run that naively, and your GPUs spend half their time sitting idle, waiting. Microsoft had to invent new infrastructure from scratch to make it possible. Section 2. Reinventing the training process. So how do you train a model that constantly wants to pause, calculate, and recheck itself? Microsoft's answer was nothing short of engineering wizardry. First, they built a distributed code execution system, capable of handling 45,000 concurrent tool calls with almost no delay. Think about that. Tens of thousands of little AI-generated Python scripts running simultaneously, all without clogging up the pipeline. That's like having a classroom of 45,000 students asking questions at once, and every single one of them getting an instant answer. Next, they separated the code execution environment from the main training system. This isolation prevented bottlenecks while still keeping throughput high by balancing workloads across CPU workers. Essentially, they built a traffic system where no single GPU ever gets jammed while the others sit idle. And here's the brilliant part. They didn't assign GPU tasks in a fixed, rigid way. Instead, the system dynamically scans for real-time GPU cache availability and hands out tasks accordingly. It's like a perfectly tuned orchestra where no instrument ever rests unnecessarily. The result? Zero wasted potential. The outcome of all this careful engineering is staggering. The entire model, something that competes at the very frontier of AI, was trained in just 1 week on 64 AMD MA300X GPUs. For context, some rival models require thousands of GPUs running for months to achieve similar performance. The efficiency leap here isn't incremental, it's a quantum jump. But here's where things get even more fascinating. The algorithm behind this training. Microsoft used a method called Group Relative Policy Optimization, with resampling on correct GRPO-RC. That might sound like jargon, so let's break it down. In most reinforcement learning setups, the model is rewarded if it gets the final answer correct, even if its reasoning path was messy, inefficient, or full of lucky guesses. That's like praising a student for landing on the right number without caring if they cheated along the way. GRPO-RC flips this logic. Instead of rewarding brute force, it rewards clean, efficient reasoning traces. The model sees failed attempts because failure is crucial to learning, but it's trained to prefer reasoning that is neat, structured, and tool-driven. Over time, this produces not just an accurate model, but one that thinks with elegance. And that's a game changer, because in the age of AI, speed and accuracy aren't enough. Efficiency and reliability, the ability to solve problems without wasting energy, time, or computation, are what will separate leaders from followers. Section 3. The results outperforming giants, the numbers speak for themselves. On the AME24 benchmark, R*2 achieved 80.6% accuracy. On AME25, it scored 69.8%. To put that into perspective, it outperformed DeepSeek R1, a colossal 671 billion parameter model. And here's the kicker, R*2 used far fewer reasoning tokens, around 10,000 on average, compared to DeepSeek's 17,000+. Think about what that means. A smaller, leaner model is not only beating a massive AI, it's doing so while thinking more efficiently. In human terms, it's like a college freshman solving problems faster and cleaner than a team of PhD mathematicians. And the versatility doesn't stop at math. Even though R*2 was trained primarily on mathematical reasoning, it showed impressive transfer skills in scientific reasoning tasks and performed strongly on general alignment benchmarks. That means this isn't just a specialized math bot. It's a flexible, adaptable intelligence, capable of applying its reasoning strategies to entirely new domains. Here's where it gets truly mind-bending. When researchers peeked inside the model's reasoning process, they discovered something new. In addition to the expected forking tokens that encourage trying multiple solution paths, R*2 developed reflection tokens. These are signals that emerge when the model directly responds to external tool feedback, such as analyzing Python output and adjusting its reasoning accordingly. In plain English, the model isn't just thinking inside its own head anymore, it's actively learning from the environment. That's a huge leap. Traditional chain of thought reasoning is inward-focused, but R*2's reflection tokens prove it can reason interactively, adjusting in real time. Pause for a second and think about the implications. We're moving from static reasoning, where AI is locked in its own bubble, to dynamic environment-driven reasoning. This is how human intelligence works. We don't just think in isolation, we test, we adapt, we reflect. Microsoft has just built an AI that starts to behave the same way. And this breakthrough, it's just the beginning. Because while R*2 is revolutionizing reasoning, Microsoft is also reshaping AI in another domain entirely, speech and language. Section 4, MAI Voice 1 and MAI 1 Preview. The next AI wave reasoning is one thing. But communication, the ability to speak naturally and understand language fluidly, is what makes AI personal. And Microsoft just launched 2 new models that could redefine how we interact with technology. Let's start with MAI Voice 1. This is no ordinary text-to-speech system. It can generate 1 full minute of high-fidelity, natural-sounding audio in less than 1 second. Yes, you heard that right. 1 minute of speech, generated almost instantly. And it does this using just a single GPU. For context, many existing voice systems require multiple GPUs and often still take several seconds to generate high-quality audio. MAI Voice 1 obliterates that limitation. The speed, combined with its ability to produce nuanced, natural voices across multiple languages, makes it ideal for real-time applications, whether it's interactive assistance, podcast narration, or even embedded into consumer devices, where compute resources are limited. And here's the kicker. Microsoft is already deploying it. If you've been using Copilot for daily news summaries, some of those smooth voice updates you've heard are powered by MAI Voice 1. Inside Copilot Labs, users can already experiment with turning text into audio stories or guided narratives. The efficiency is so high that for the first time, high-quality speech AI can realistically live inside consumer devices instead of being locked away in giant server farms. Now let's talk about MAI 1 Preview, Microsoft's first fully in-house foundation language model. Until now, Microsoft has leaned heavily on external partnerships, most notably with OpenAI's GPT models. But MAI 1 Preview marks a strategic shift. Trained on a colossal 15,000 NVIDIA H100 GPUs, this model represents Microsoft staking its own claim in the foundational AI space. Here's what makes it unique. It's not built to be the biggest or most intimidating model. Instead, it's designed for practical everyday use, optimized for instruction following, conversational flow, summarization, and helping with real-world tasks like emails, schoolwork, or productivity. It's consumer-friendly AI with enterprise-level muscle. Already, MAI 1 Preview is showing up on Microsoft's Elmar Arena platform, positioned alongside other industry heavyweights for comparison. And within Copilot, it's being rolled out carefully, starting with text-based tasks, gathering user feedback, and refining before scaling. This cautious deployment strategy signals something important. Microsoft isn't chasing hype, they're building for the long game. Conclusion: so what does all this mean? In just one announcement cycle, Microsoft has redefined 3 pillars of AI reasoning, speech, and foundational language models. They've shown that raw size doesn't guarantee intelligence, that efficiency can crush brute force, and that AI can now adapt, reflect, and communicate in ways that feel shockingly human. But here's the haunting question. If a single company can pull this off in a matter of weeks, what happens next year? Next month? Tomorrow? Because AI is no longer crawling forward, it's sprinting. And if we don't keep up, we risk waking up in a world where the machines aren't just faster, they're fundamentally smarter in ways we can't predict. That's why staying aware matters. That's why every breakthrough counts. If this deep dive gave you chills about where we're headed, drop a comment with your thoughts, hit that like button, and make sure you subscribe. Because trust me, the next wave of AI innovation is coming sooner than you think, and when it does, you'll want to be ready.